This is about Huawei routers and what we found when we looked at them. So throughout the slides, you will have those section slides that contain strings from the actual binaries, just for to show how much amusement we had looking at those devices. So let's start. Essentially, why did we look at Huawei? Some of you know that I was hacking Cisco for over a decade. That got old. They never learned. And so they actually did a little. But nowadays, the second largest telecommunications vendor worldwide is Huawei. And so much of our internet infrastructure now depends on them that I thought, well, we should actually take a look on the devices and how good they are. So when you look at the company, it's a pretty large company. They have like over 150,000 employees. 3 sections: telco networks, global services, and devices that most of you probably know, like USB sticks and stuff. The global services group essentially operates many of the networks that run Huawei equipment, and we will see why a little later. So this is stuff they do. So you can see they have like the full product range of shit that telcos usually buy or prevent from buying. But what we're looking at is actually what they call the data communication equipment, so the routers. There's 2 major branches of Sirius. It's the NE, the network engine series. That's the telco size stuff. And the AR series, that's more like your home routers or branch office routers, like smaller devices. There's also Huawei 3Com, which is another company, or used to be another company, that was actually acquired by HP. So we didn't know that for our talk at DEF CON, and had to find out why the HP people were all freaking out over us, because we're like, hey, we talk about Huawei, what's your problem? So they actually share some code base with Huawei's software now, and actually already provided testing equipment. An interesting joint venture from the past is Huawei Symantec. What can possibly go wrong? And obviously this joint venture does not exist anymore. So when it comes to product security, we, for the DEF CON talk, we went to their website and tried to figure out, like, okay, so, oh, here's a link, product security. Yeah, it contained like long blurb that how important this is, but there wasn't actually a product security team visible to the outside. By now, I know that they actually had one, but they never dealt with hackers before, so there wasn't any information. And following our DEF CON talk, they published a cybersecurity practices paper that talks about their software security practice cycle. And how should I say that? I'm not entirely sure they talk about the same company. So, as I said, the security handling is now, after our DEF CON talk, a little bit more visible. So there is actually a product security incident response team now. And there's contacts in OSVDB. So if you find Huawei ODE, you can actually let them know. The product security advisory strategy is still not what I consider industry best practice, because it's provided only for customers. I actually wonder how they know who their customers are, because where we buy the routers is some reseller, and I don't think they keep track of who buys the routers. So we were provided with preview versions of the advisories to the bugs we'll be discussing here in PDF format. Anyone else feeling funny when you get a Chinese PDF? So yeah, that made me look a little bit weird. So the product security patches are not really easy to tell on the software, so it's really hard to know if you have a vulnerable software or not. And there is a UK-based Huawei Cybersecurity Center that, according to their own statements, actively audits Huawei code. Maybe. As you can see, like this is 2 days ago, this is still work in progress. So the website now has a security advisory sections, content upcoming. So let's talk about VRP. VRP is the versatile routing platform. There is multiple branches known, and by now I would want to clear up this myth about Huawei having stolen Cisco iOS. Man, nobody ports this shit. Cisco is happy if they can compile it for their own machines. So it was very unlikely from the start. So according to Cisco's legal documents, the problem Cisco had mostly was that the enhanced IGP code was copied verbatim, including bugs. And so Huawei actually tried to make the CLI, the command line interface, look the same way as Cisco, so people would not need to learn new shit. Unfortunately, some lame ass then decided, wow, that now means that the documentation actually looks like our documentation, and copied that. So that apparently was the whole legal problem. And it's long settled. So what we deal with today is VRP 3 and 5, which are VxWorks based, respectively 3 and 5 VxWorks. According to some messages I received from Huawei, the VRP 5 is a large rewrite, and we will see about that. I've also seen references to a VRP 8, but I have absolutely no idea what it is. So when you find a file, it looks like this. This is for switch. So you have the platform, then you have the VRP, in this case 5.2, and then some digits and numbers that really don't make sense. And then there's also different names that you can find the software on. So for OEMs, it's called Comware, and sometimes it's called VXLS, and different names. So thanks to the brilliant man, H.D. Moore, I actually have some solid data on how the versions are distributed. So you can see that 5.5 is by far the most used version. The 3 series is also still around. And then I grouped the data I have, which is like 130,000 IP addresses plus version information, into the equipment. And what you will see is, ignore the switches, because they're Ethernet switches. What you see then is it's all the large-scale telco equipment, so things that fill an entire rack. That is because the financial difference, the cost difference between a large Cisco machine and a large Huawei machine is the greatest. So here's the incentive of buying Huawei, is because the equipment that costs you a shitload of money suddenly gets significantly cheaper. And so, it's good for the bottom line and the stock market and everything else that is so good for mankind. So when you want to deal with the routers, what you're looking at is the standard interfaces that every router has, like command line interface through SSH, Telnet, console, web-based configuration, netconf, SNMP. Then there's some weird stuff like the Branch Intelligent Management System, BIMS. And if you're German, it sounds really funny. So this is actually like a client-side system, so you can trigger it by DHCP, and then it goes out to a BIMS server. The only one I could find is actually made by HP, and then gets additional configuration settings, like different DNS server or whatever. The language settings for the COI are, you can set this to Chinese or English. And here comes the reason why everyone has Huawei people operate their crap, because the debug functionality, if you ever set up a network that is bigger than one router, you know that you need debug commands. Debug IPsec foobar, IPsec never works. So in order to do that, you turn on the debug commands, but you don't see shit because they're only available in Chinese. That is a pretty good strategy if you're selling professional services, actually. So once you're in, and it speaks English to you, you find a couple of levels of hidden commands. The most important is underscore. Underscore actually gets you into developer commands that are quite useful for exploit development. And then depending on the platform, you have, special diagnosis commands that usually want a password. Always try the vendor name. Vendor name is usually what the password is. So in this case, it was Huawei 3Com. So when we look at the images, you can download them actually from the website. There's some authorization process involved. I have no idea how that works because I don't have a legal account. So essentially, in order to get to the images, the easiest way is simply buying routers, because in the default configuration, they come up with an open FTP server, and you can essentially FTP the image down. And then, you have the image. So that's what we did, because it's also legal. And then you look at the image format. The headers and the image formats differ greatly between the platforms. It's actually a fun game. It usually takes just a couple of hours to reverse the format. But it's really interesting. I was wondering if they maybe have an internal competition on creativity in bundling up files. So what you have is different archive formats that all look like Chernobyl's grandchildren of tar, right? So they're all free versions of tar in some way or the other. We haven't found any cryptographic protections yet, which doesn't mean that there are none. I just haven't seen any. For the really small devices, you get one binary out. The bigger the device gets, the more stuff is in there. So like the NE80 and 40, like the big telco machines, they load 256 different files on different data boards. ARM, PowerPC, what have you. Also, the compression algorithms greatly vary. ARG, anyone remember ARG from the 90s? They really love using ARG. We have seen zip, 7-zip, deflate, and what's really funny, LZS, because we couldn't decompress some of the images, and we really didn't find decompression code until my coworker Greg points out that, well, but this code here speaks IPsec, so it needs to do IP compression. So maybe that's what they use. So someone thought, well, I have IP compression implemented, I can use that for the image as well. Can be done, fine. So when you unpack it, some of those archives have descriptions to the individual files. This is like this third column here. It's the description that is actually in the file. So you see that their developers are as lazy as everyone else is because they didn't put any descriptions in. And you see that you have a variety of interesting stuff in there, right? So in terms of hardware, this is all PowerPC based. So the smaller boxes, the AR18 and 28 and that type of stuff, are pretty similar to shared memory routers from Cisco or anyone else, right? They're just, little embedded devices. The bigger ones are more like the bigger AR platforms are more modular, so they carry additional code for chipsets and GSM and what have you. And then the big platforms are actually really interesting, and I'm going to look into them more because they use IBM Power NP network processors that do classification, encapsulation, and that type of stuff in hardware, and get programmed in Pico code, and whatever those NPs then do gets handed over to the application CPU. This is how you get performance. Cisco uses a very similar design for their boxes. But it gets more complicated the bigger the box is. So what default service do we have? Usually by default, with the smaller boxes, like with all the boxes you have SSH and FTP open. With the smaller boxes you also have HTTP for web management, web-based management. You often see Telnet, XOT is very common, interestingly. Some branches of VRP also automatically load H323 code and open like 10 ports. What can possibly go wrong? It's H323 is really easy to parse. Don't try it at home. The functionality that you can disable default services is relatively new. So even in the security advisories that we saw, for older platforms, they actually tell their customers to use ACLs to block traffic to port 80 because you can't turn off the web server. And then, as I said, BIMS is a client, so the other way around. Code quality. You find a shitload of re-implementations of functions that we actually don't use in this century anymore. So everyone seems to have their own implementation of memcopy. There is variations of string copy that are really interesting. And so, for example, the number of calls to sprintf, notorious function, is actually a linear function over the device price. So the bigger the machine, the more sprintf calls. So for a small 3.4 VRP, we're talking 10,000 calls to sprintf. The next bigger one has 16,000. VRP 5.5, apparently a rewrite, was apparently a rewrite done with the same coding practices because it has 27,000 sprintf calls. And that is just the main image. The SSH server is a rewrite. So that is really brave. I mean, it took us a decade to get OpenSSH right. And we're still not sure about it. You know, rewriting it is not really a good idea, especially if like you SSH in, this is for VRP3, I have just failed to test it for 5. You SSH in and your OpenSSH client says, no, I'm not gonna talk to this thing because like the RSA model is too small. So you actually have to force it to even connect. And then, you know, the null page, which, you know, the null page in memory, which is fairly important for null pointer dereferences and similar stuff, is not just mapped, it's read, write, execute mapped. Someone was really nice to hackers. So, let's look at the web management interface. So, this is a Huawei 3.0, as you can see, but not much difference. This is how it looks like in Chinese, obviously. I mean, you can switch it to English, but I wanted to show how Chinese looks. This is pretty nice. It actually only works on Internet Explorer. Some versions of VRP, actually, it doesn't work at all. So, like, you get fragments of JavaScript. It has a session ID called user ID. That session ID is 4 bytes long. One of them is ignored. One of them is fixed. One of them counts the concurrent session. And the last one counts up. So that is pretty much as predictable as it gets. So if someone is already logged into the router, you can as well, obviously, which gives you direct full administration control. This is me stealing the configuration from a router. Yeah, but if you have web management, you also, I see the Loft guys see a reference here. So you also have a web server, right? So the web server tries to determine right in the beginning, before logging, before everything else, whether the resource you're asking for is something that you need one of those complicated session IDs for. So it has all the web content in a zip file. So the obvious way to do it would be to take the zip file dictionary and see, you know, which files are in there. If it's one of those files, I give it out for free. Otherwise, I will want a session ID. No, what they do is a series of string compare functions. And if it turns out to be a resource that is probably not requiring any authentication, the URL gets copied into a buffer. That one is on the stack, and it is too small. So we have a very classic stack-based buffer overflow. Any of those will work. We get pretty much direct control of a shitload of registers and the whole stack. So everything that's red here. So that's a really nice bug to play around. So the only thing we need is a jump target. So where do we jump to? Obviously, we can't use null bytes, this being a string copy. And there's, the image base is null byte poisoned, so we can't really use that. But for the purpose of the exercise here, we just stay image dependent. And we simply reuse a move to counter register, branch to counter register instruction sequence that we find somewhere in the code, return-oriented program for kids. So you jump to only one sequence. Yeah, and then we only need shellcode, right? So for the shellcode, Huawei was nice enough to provide a pair of functions that have no privilege check involved and execute whatever you give them as an argument directly as if you were logged in with full administrative privileges on the command line. Those are pretty useful. I mean, the functions are, the addresses of those functions are image dependent. However, funnily enough, a couple of years back, I wrote and published a disassembling shellcode for Cisco that disassembles the code in memory and finds the functions by building string references. That one works for Huawei because they're both using PowerPC. And so if you want to be image independent, use some of my earlier work. So the strategy essentially for exploitation is we do a simple XOR encoding to get rid of null byte issues and spaces and other things that fuck up HTTP. We decode this all inline and send a command sequence. And this is a command sequence to set a password for the administrator and then ping my host because I want to see whether this worked or not, right? And that's all the shellcode you need for that. It's really not that complicated. I mean, very almost basic PowerPC exploitation. If you've ever done PowerPC exploitation on older MacBooks, this is exactly the same thing. So you play some tricks with the instruction encoding for example, to have syncs, to get rid of issues with the caches, and then you iterate over the commands. This is how that looks like. So you send your HTTP request, you get an echo request, and send back an echo reply, and then you turn it into the machine, and you're good. So now stack overflows are easy. We wanted to also see how heap overflows work, like heap corruptions. So we started to look for vulnerabilities that are heap overflows. It is fairly difficult because everything you find is a stack-based buffer overflow. So after long searching, we found this BIMS client, and I found it interesting because client-side exploitation on routers is a pretty rare thing. And so my coworker Greg looked at how to actually exploit this. So the vulnerability is pretty straightforward. The BIMS client is actually an HTTP client. So what it does is it sends out a request with the funny statement that this is going to take less than 10 minutes. I don't know how fast the internet in China is, but 10 minutes for an HTTP request is pretty long. So what it does then is it takes the header that it gets back, takes the content length provided by the web server, trusts it, and allocates memory accordingly. Interestingly enough, it already has data in hand, namely the header, which is then copied into the buffer. So we provide the size of the malloc, and we provide the data that overflows it. pretty straightforward. Now the only thing we need to do is we have to look at the allocator. When you look at the allocator in disassembly, it becomes quickly clear that this is a bin allocator, because there's like fixed numbers that are compared, and then there's different free lists and use lists and stuff. So you look at the allocation and see what sanity checks we have in there. There's some magic numbers. There's a pointer to allocator structure, and so on. And then you look at the free, and the free actually goes ahead and does a straightforward pointer exchange. So this is how a heap chunk would look like. There's the chunk header, then the pointer, and user data, or if it's a free block, there's additional data that manages free blocks. Very typical heap layout from the 90s. So, as I said, it's a bin allocator, so each bin has its own free list. This structure, the PGH structure, has a pointer to the respective list, and malloc essentially, then if it takes out a block out of the free list, essentially again, just takes the first block and performs a pointer exchange, which gives you arbitrary memory right if you provided the pointers. So, old school DR malloc. We can reuse FRAC articles that we haven't looked at in years. So we simply overwrite the metadata of a free chunk, and when the next chunk is malloc, then everything is fine, right? So just to illustrate, this is how it would look like with free blocks. And we take some assumptions on the size, which we can because we can control it. And then, when a block is malloced, it is taken out of the free list, and then when it is free, then it can be malloced again, and here we get control, because we can write some value into some important piece of memory that we still have to determine. There's a couple of things to take care of, obviously. So we have to make sure that the sanity checks go through, but as you have seen, they're not very extensive. Like, compare that to what Mark explained yesterday on the iPhone heap. This is really simple, this is really predictable. So the next question is, like, how do we make the heap layout more predictable? So we're looking at different bins. One bin turns out to be 512 bytes. And we can allocate more of those, so we can fill the heap and essentially massage our way to a heap layout that is the way we want it. Luckily enough, every time you make a TCP connection to such a device, it allocates 512 bytes for control structure. So this is how you control the heap allocation remotely. You just connect to the device. Now, we need a couple of addresses that we predict, and that usually doesn't work too well, because there's a lot of variety in images, even for Huawei. It's not as bad as it is with Cisco, but having a target list and hard-coded pointers just sucks. So Greg decided to make it even more unreliable, as he said, and actually try to heap spray the device. So due to the nature of that bug, it's really, really easy to heap spray, because you provide the content length and you provide the data. So using multiple connections, you can just spray the entire heap, or other strategies apply as well, right? If you have a memory leak or whatever, then you can use that. And then there's the question, what would we overwrite? That would again be image dependent. So if we would try to patch the code or write into some data structure or whatever, But remember that I said that the null page is mapped. So the null page contains the PowerPC interrupt handler routines. Remember in the MS-DOS days, you had the interrupt vector table that we always had to modify in order to write code that Miko would later find and write signatures for. That is similar. However, on PowerPC, you actually have the code in those places. So you have 256 bytes space per interrupt to handle. And so we can essentially just write somewhere there. Now we have to choose an interrupt. We could use something that is triggered by timing. However, there's also the interrupt that gets triggered for invalid memory access. You know? And since we're fucking around with the heap quite a lot, this might be, you know, a good place to start. So, since our heap voodoo is pretty much guaranteed to cause a crash sooner or later, we just write our code directly into the interrupt handler, and you know, it gets triggered by itself, so to say. So once we have code execution, we can clean up the heap if we want to, do whatever we want, and then, you know, exit the interrupt handler. Another good thing, it is the interrupt handler, so we don't get interrupted. That is also good. And this is then the exploit that Greg wrote. It is called the visitor because when the BIMS client activates, it will say now visiting the BIMS server. So this is the visitor, and this again gives you code execution, executing arbitrary commands. Now we come to the question that is always given around when you talk about Huawei. You know, the first question is always backdoors. So to save you the time of asking, here's what it is. It is very often claimed that Huawei backdoors every device, and then the Chinese government can read all your email and watch all your porn, as if they don't have their own. And so far, nobody has actually discovered backdoors in hardware or in the VRP code. Seriously? Given the supply of vulnerabilities and the relative ease of exploitation, I don't see why you need one. You know, it's a question of interpretation, right? So even their senior VP said, like, what they have been calling backdoors are actually bugs in our software. Perfect deniability, right? So actually, with so many carriers having Huawei operate their networks, I would be more concerned about the network management systems and the remote access to them and everything that comes after that. Because, you know, you don't need to break into something that you have the root password for, right? Which usually in operations is the case. That said, when I looked at the bootloaders, you know, between the string password and password, I found funny looking strings. And so by the definition of a backdoor being a hidden method of bypassing normal computer authentication systems, that pretty much fit the bill. So what you see to the right is a very, very straight operation. So what we have here is, so what we talk about here is the bootloader password, right? So what we have here is a user input and the password that is stored in flash and a string compare. If that worked, good. If that didn't work, it takes the user input and a fixed string, in this case 8070 BSP, does a string compare. If that worked, also good. In my book, that's what the backdoor is. Now, what does give you that backdoor? The thing is, the bootloader password is important if you deploy machines outside of your premises. Because you need console access in order to get to it. But when you have no bootloader password, you can interrupt the bootloader and can say, well, boot without configuration. And that gives you access to the machine. Also, this password is also used, like the fixed password is also used when you reset the password. It asks for the old password. You can also use that fixed password for that. And that is really useful if you buy used Huawei equipment that actually had a password set, and the seller failed to recognize that they need the password. So if you buy used Huawei equipment, you want to have those. So we're still collecting them. I'm not entirely sure who Superman is. And yeah, it's interesting because they're not documented, obviously, and we're still collecting for other platforms, but the bootloaders are packed differently, as I mentioned, with the images, so that kind of sucks. Put some perspective on this. So this backdoor only works locally or through a terminal server. If you have a terminal server and someone gets to the terminal server, you're fucked. So you can load the VRP image without configuration, then change the passwords, for example, and reboot the machine with configuration, and you're in. So if you have equipment deployed outside of your premises, not good. It should also be noted that this practice of having vendor backdoor passwords is nothing unique for Huawei. PC BIOSes used to have that for a long time. Other vendors do that. Our famous Siemens in Germany has probably more backdoor passwords than regular ones on their equipment, and all their daughter companies as well. However, because of this being network equipment and usually deployed all around the place, there's a really good reason that Cisco at some point introduced a no-service password recovery, which is exactly that. It disables the possibility to get into the boot ROM and load the machine without configuration. So it's something to consider here. And that already brings me to conclusion. So VRP actually suffers from 90s style bugs and respective exploitation. So not good. They seem to be ramping up product security now. Let's see where that goes. The current state of our research, you never know, it's a lot of code, but the current state is that the fear of government backdoors is pretty much exaggerated. However, anything local access is undefendable right now. Like, everyone can read bootloader code and find the string compares. And with that, I would like to close, and if you're concerned about your network security now because you're running Huawei equipment, don't yell at your network people, fire your CFO. That's the guy who made the decision to buy this crap. Okay, thank you. Any questions?